30 years ago, last month, a completely unknown author published his first novel. The author was William Gibson, and the novel was Neuromancer. Has anyone here read Neuromancer? I got one back there. All right. So it was an instant hit, and it really helped shape the popular imagination of what the future of the internet, or as Gibson called it, cyberspace would look like. So in honor of that 30-year anniversary, I want to start with one of my favorite quotes from Gibson, which is that the future is already here. It's just not evenly distributed. And let me tell you, SDN is this kind of future, right? Because at a recent Gartner event, they did an informal poll, and how many people said they have significant production deployments of SDN? 1%, okay? 1%. It's like SDN needs an Occupy movement, okay? The other number up there that's interesting is the 23% that asked the perennial question, well, what is SDN, right? And if there was an acronym that had an identity crisis, well, SDN certainly is it, right? So I encounter this on a daily, weekly basis as I'm called on to talk to our customers about how do they use SDN in their business. So I do the OpenFlow, I do the 1PK overview, I show some really cool demos that I wrote. And you know, more often than not, you know what the response is? Hey, that's cool. But what I really wanted help with was automating the configuration of my access list. Can you help with that? And at first what I would do is what we call the technical marketing shuffle, where I'd say, well, let's think about what an access list really is, right? It's a drop action on a flow in TCAM, right? And we can do that with OpenFlow. And then after a while, I thought, you know what? I need to confront this head on. If people want to do configuration automation, then I should be able to help them, right? Baby steps are better than no steps in the Occupy SDN movement. So that's what I started to do, but it meant I had to expand my definition of what is SDN. So today I want to give out a quick shout out to 3 technologies that I'm increasingly talking to customers about to solve their real world pragmatic problems. The first one is good old Netcom, right? I mean, you don't get any more old school networking than an IETF protocol, right? And there's a ton of interest in this protocol right now, especially because of the increased focus on Yang data models, right? So the promise there is that we can standardize the actual content of what goes in to the Netconf protocol, which eventually will give you vendor-neutral configuration management, yay, right? Netconf is very sophisticated when it comes to configuration. You can look at multiple data stores. You can do fancy things like commits, rollbacks, and locking. And a lot of the traditional service providers and larger enterprises that I talk to really feel that Netconf is absolutely essential to their future automation strategies. And this is just a little snippet of what Netconf actually looks like. It's all encoded in XML, which drives some people crazy and which some other people really like. But not everyone believes that Netconf is the solution to world hunger, right? So for the last 5 or 10 years, there have been hordes, and I mean hordes of web developers out there who have been totally geeking out on this thing called REST, right? Representational State Transfer. Now, if you've never heard of it, don't worry, because if you know how a browser works, then you understand how REST works, okay? It is literally an application that does an HTTP operation, a GET. And the response it gets back, instead of being encoded in HTML, which would tell a browser how to display data, it's in XML, or actually more often frequently is JSON, which is a lightweight alternative to XML. All right, JSON. So it's actually the data itself. And this is an example up there of a query I did on a REST API from Twitter. And if you look at something like Programmable Web, which is an index of web APIs today, there are literally thousands, I think it's over 11,000 the last time I checked, APIs like this out there today. Everything from Amazon Web Services to Google Maps to Twilio to Twitter to any web weather service that you can think of. There are REST APIs that can do this for you. But it's not just web services. We now see networking devices that provide REST APIs. We see controllers that provide REST APIs. And this can be to set configuration. It can also be in these 2 examples I just showed about retrieving operational state. So REST is not sophisticated, right? It is simple CRUD. You have none of those fancy operations that the really smart people in the IETF put into Netconf. And so it's, on the other hand, it's incredibly simple, all right? But it's not standardized. It's a style, not a standard, all right? So you have to look at all of those pros and cons. Another thing to realize is that there aren't just a bunch of web applications out there that expose REST APIs. There are a bunch of business applications and other kinds of enterprise applications that can consume REST APIs. So if you have a REST API on your device, it makes it easier to integrate that with an existing device that already consumes REST. The third shout out I want to do is to this whole group of technologies that come from yet a third group of folks, and these are our friends over in IT, right? Smart server admins, or at least lazy ones, have always been good at writing scripts to automate repetitive tasks, right? So installing software, installing patches, doing the configuration, those have all been things that have been scripted for a long time. But with the rise of virtualizations and the number of exploding machines that people actually have to manage, even scripts are not enough. So this has led to the rise of several automation frameworks, or tool chains as they're sometimes called, under the umbrella of DevOps. And there are a ton of them out there. A lot of them are open source. There's implementation differences, but all of these basically work the same way. You have a server where you define what you want the ideal state of your target to be, and then you communicate that through some mechanism. Some of these things use agents, some of them use SSH, some of them actually use things like Netcom, but you communicate that desired state to the device, and in most cases the device is responsible for implementing that policy and bringing it up to snuff. So these tools have been very successful for server admins, okay? They have allowed, an individual admin to go from managing hundreds of servers to literally thousands, and in some cases, tens of thousands of servers by utilizing centralized config management tools such as these. So, the natural question is, sitting here on the network side of the house, can we use these same kind of tools, unmodified or with slight modifications, to give us those kind of scales and efficiencies for networking devices today? And so you're seeing a lot more support for an interest in these tools from the vendor side and as well as from the community side. So I think this will be a really interesting and productive place. How many here have heard of these technologies? Puppet, Chef, Ansible? Okay, so I'm not telling you anything that you haven't already heard of. So we have 3 different technologies addressing the same basic problem space, and they all interestingly come out of 3 different technical communities, right? Which, first of all, I think reflects in an interesting way on how interdisciplinary networking is becoming. And I'm not just saying that because I'm an interdisciplinary kind of girl, but I am. And the second thing that it leads me back to is that perennial question. And I'm going to do it. I'm going to take the plunge. I think I'm going to come up with yet a new definition of SDN. And I'm going to call it software-designed networking. Because a lot of what I see happening is that we are taking the principles of software design, and whether that's the sort of separation of concerns that you would see in the control and data plane separation for OpenFlow, or the interest in APIs, or the sort of data modeling we're doing for Netcom, these are all ways in which we are taking concepts that are familiar in the world of software and seeing how well they apply to the world of networking. Now, some of them will work better than others, but I think it's too soon to actually start picking winners and losers. Complexity, I think we can all agree, is an acknowledged enemy of the internet of the future. I talk to people all the time who come to me with a 1,000-line access list, or they come to me with a network in which they have 5 layers of nested tunnels that they are using to try to get data from point A to point B, and they are understandably cautious about making changes. Right? And I think what that says to me is that we are approaching the event horizon of what this guy, who looks strangely like Patrick Stewart but isn't, what this guy calls complexity collapse. Not the point at which the system stops functioning, but the point at which you are afraid to make changes to it. And we can really not afford to have our networks be static in this way. So we have to start importing these ideas, these designs, these tools from other domains, and particularly the domain of software, because they have been grappling with the questions of scale and complexity for a lot longer than we have in networking. So the more experimentation we do in this area, the more that I see everything from OpenFlow to Netconf Yang to REST APIs, the happier I am. So thank you very much.